So this example is just going to show you how friction can affect the motion of an object. A hockey puck leaves a player's stick with a speed of 9.9 meters per second and slides 32 meters before coming to rest. Find the coefficient of friction between the puck and the ice. You're not given a lot of information here, but you are given all of the information that you need. One of the most obvious things that may feel like it's missing is the mass of the hockey puck, and in fact you'll notice in this example that I think it's missing too as I'm going through it, and then recognize towards the end that I never needed it. And you will see why, and I will point it out. So what we do know about the hockey puck is that it starts off with an initial speed, initial velocity of 9.9 meters per second. We know it has a displacement of 32 meters, and it comes to rest, which means its final velocity is 0. Assuming that the friction is constant, then it must have a constant acceleration. And using kinematics, we should be able to determine that constant acceleration. So using the third kinematic equation, we can determine the acceleration. Here's where I'll think that I need the mass. So using the third kinematic equation, we know the final velocity is 0, the initial velocity is 9.9 meters per second squared, or meters per second, and we know the displacement is 32 meters. From this you can calculate the acceleration, and notice that the acceleration that you calculate will be negative. So we find the acceleration is negative 1.53 meters per second squared. Now that we know the acceleration, we need to find the coefficient of friction between the puck and the ice. Since the only force acting on the puck is the force of friction, we can set the force of friction equal to the puck's mass times its acceleration, using Newton's second law, and from that calculate mu, coefficient of kinetic friction. So the force of friction is equal to mu times the normal force. Force of friction has to be equal to the object's mass times its acceleration. So if we solve for the coefficient of friction, we find the coefficient of friction is equal to 0.16, which implies a relatively smooth surface.